Alright, today we got a little bit of a wheel shake in the front of an automobile. Have no idea if it's a tire, a rim, a rotor, or the mounting flange for the rotor itself. Of course, the shimmy is along with applying the brakes, which is very heavy, and not even applying the brakes, just standard driving's a shimmy. So that almost omits just the rotor being worked itself. So first off, we're going to do a radial and lateral runout of our wheel assembly. Now this tire does have the blocks on the outside, as we talked about in tires on that, and it does have the ribs in the center, which gives me a pretty smooth device right in the center on this, especially when they get a little bit of wear on those. You can see I've taken this dial indicator that's on a stanchion off the floor, mounted securely, and we're going to see and check the radial runout at this point. If we didn't have a rib type tire with a smooth tread of this, we could put some duct tape around there, and it actually helps smooth out all the bumps, and we can take an average of this. So at this point right there, we can go through and zero our dial indicator itself then, if we need to, and then we're going to rotate the wheel and tally up the number of radial runout that we have. Of course, on the low side it goes down to 80. Still at 80, which is only a negative 20 thousandth to where I started. There's a 70, 50, and we should be coming back up if the dial indicator isn't bouncing around and moving and so on there. And it might be slipping a little bit on the floor of what it did right there, so let's find out. And it did. I can see the bottom of it. You'll have that problem also along with that. If I put my big foot on this guy and balance that out, and we try it again, and we'll go several times to get everything smoothed out on this. Note that it never came back. There we go. Now it's settled out. There's a 90, there's a 0, a 3, and so on there. With that, the oscillation on that, yeah, my device is shaking because I do have a very tall pedestal on this off the floor on that. I could shorten it up and so on. I could get the car closer to the floor, but we've seen that it was minimal amount of radial runout on this car. Again, one more time, get it to balance out. And the dial's not making complete revolutions, which is less than 100. It's not even making a half of a revolution, which is 50 thousandths. And the radial runout of a tire is up to 80 thousandths of an inch at the maximum on a larger tire before vibrations is felt. So the radial runout's pretty darn good on this. So let's go over and try to measure the lateral runout. A little bit harder on a block tile style wheel, but I think we've got a smooth enough area right here that I can take the dial indicator, and with a few adjustments we can manipulate this around so that we can all get a view of it. We can get the wheel lined up. We can then also go in and preload this guy a few thousandths of an inch, as we see right there. And I could actually put a little bit extra weight on the pedestal itself then, and that then will give us a little bit of a substantial support. I could take this and zero him out, and then I'm going to rotate the wheel 3 thousandths, 20, 20, down to 70, back to 20, down to 70, and 70 and 20 gives us a total of 90 thousandths. 40 thousandths is the maximum runout that we do want on that, because vibrations will be felt at that point. Now, the runout we had, is that in the rubber, is that in the rim, or the rim mounting? So if I take our dial and I move him on back here, and I come to a point on my rim assembly that I can then align the wheel, because the wheel needs to be steered, and this is going to be a little tough. You're going to have the same problem though. And so we're going to lower it. You can see the direction of the wheels the same as the rim. The rim does not have any weights in it, so I'm not going to run into a wheel weight assembly. Height adjusted. I'm going to lower you a little bit so that you can then get a view of the dial indicator. Right there's a gorgeous shot. We'll make you level. Come on up this way, and we can see how the dial's going to run right on the outside bead of the rim. And again, there is no wheel weight on this. Now I'm going to zoom in a little and get a little more light on the face of the dial. And if we get a little bit of backlighting on this thing with my big fat belly in the way or so on like that, we can then rotate the wheel and see if there's any run out on this wheel. And what do we have there, sir?
About 80 thousandths.
80 thousandths? Okay. 40 thousandths you're going to feel a vibration, and of course the smaller the vehicle the worse it's going to be. So 80 thousandths is too much. Let's remove the wheel, and with that then we're going to look at the rotor to see if it's something between the wheel or something between the rotor assembly on this automobile. So I'll get my dial out of the way. Go ahead and take that wheel off here quickly, sir. I only had one holding it on, but that didn't make it wobble. Now comes the point that I can go in and I can look at the flange on the rotor and see if maybe it's this guy. Now of course I'll bring you, I need a little bit more stanchion here on this to get into this, but we can measure the run out. Now this dial, of course, we can see how difficult it is there, so let's go to another device that you'll have to learn to get used to using it also, which is a good thing. Alright, now I want to hook on to something with these vice grips that has the same amount of mounting as these rotors themselves do. So I'm going to look around here. I see a backing plate, which again mounts to the same place. So I'm going to grip on him. And then I can take a dial indicator and set him up. This automobile's, we've been having a little bit of problems finding a hub assembly for this. We know that we've got some run out on that. And do we know if anybody even has one yet or so on that?
I found you one.
Okay. Now, they're all set up on this, and I'm going to measure to see if I got any run out on where the rotor actually attaches. Right now I don't have to put lug nuts on to hold the rotor onto the flange, because we have the original Phillips screws on this fella holding him tight, so again it's pinched in there very well. Now with our dial indicator, I'll give you a 0 mark on him then, and we'll see if we get a half a revolution or so on. Of course, as we know, a half a revolution is 50 thousandths of an inch, so we can work off of that. I'm going to reach in and grab a CV joint and attempt to turn it. Go ahead and turn the other tire on the other side. What we'll do then, nothing happening over here. We got a brake that's really hanging up on us. Okay, I hit it with my hand. We're at 50 thousandths there, and here we go. There's 10 thousandths, back to 50. And we're going to see if it returns to the same spot. If it returns to the same spot, then we are consistent. So we're seeing about 10 thousandths of an inch run out on this flange right there. As you can see, 12 thousandths. With that 12 thousandths, it does multiply exponentially as we come out further on the diameter. Let's find out then. We're going to remove the brake caliper, we're going to remove the rotor, and check the hub then at this time then on this.